everybody, and thank you for coming to see my talk. So today I'll be presenting a pilot study which looks at the distribution of multi-verbal expressions in Kera'a using a multivariate analysis. Now, I do encourage you to take advantage of the online format and pause the presentation anytime when you'd like to take a longer look at something, as I have included quite a few examples and further explanations that I won't go into for the interest of time. I'd like to start the presentation off by sharing with you two quotes. The first from Savicki in 1990, who said that what makes serial verbs interesting is the fact that they cut across established categories, exhibiting properties of both subordination and coordination, and or of both syntactic and morphological constructions. And to me, I felt that this encapsulates a lot of research into serial verb constructions, which certainly resist easy categorization. And Fickle in 2010 proposed a way that we can investigate these terms by decomposing them into sets of variables or parameters, which can capture all associated variation. So that this could be done comparatively or within a single language. And it's research into the last option that I present to you today. Now, I'll start by introducing the language that I work on before looking into the complex verbal constructions in Kera'a. I'll then introduce the setup of the multivariate analysis that I conducted and go through the results and see what hypotheses it generates before finally detailing a few possible research directions. Now, Kera'a is a Trans-Himalayan language spoken in Arunachal Pradesh in India. So it's this area outlined in black, very at the border of Southeast Asia. And the today it comes from Minju, a variety of the Mido dialects spoken in Dibang Valley. In Kera'a, we find quite a few instances of two verbs occurring in close proximity to each other in a number of different constructions. So number one, we have a serial verb construction. The plus sign in the example I used to denote elements which form a single grammatical word but constitute separate verbal elements. We also have examples like number two, converb constructions, where the first verb carries a converb affix. And we have examples like three, which are clause chains, in which the first verb has a clause chain suffix. So all three constructions seem to do similar things functionally. So I decided to look at them together rather than separately, as I felt a holistic approach will help me kind of see what features are truly definitional and what is just simply phenomenal. So after looking at some typological literature, I started really looking at the multi-verbal expressions, which I term complex verbal constructions, or CVCs. And by this, I mean monocausal constructions, which consist of two verbal elements. So this definition encompasses both serial verb constructions and converb constructions, but probably not clause chains. And further investigation of how CVCs pattern within this kind of very widely defined design space of language can help, I believe, to justify positing constructions on a language-specific basis. And I also certainly hope it helps me figure out how Kera'a and its multi-verbal expressions fit in with the wider Himalayan picture, as there are many related construction types, and it's not quite clear yet how they all relate to each other. So this work today definitely represents a first step in this process. So to examine CVCs, I decided to use a multivariate analysis to explore the distribution of multi-verbal expressions in Kera'a. And through this process, I hope to answer questions like, are there clear serial verb constructions? Is there actually a converb construction? Does it make sense to group these constructions all together as complex verbal constructions? And what can the distribution of these constructions tell us about the structure of Kera'a? And I did this in particular by using hierarchical agglomerative clustering using average linkage and R. And this method groups tokens together from the bottom up, just gradually, step by step, depending on the similarity of tokens to each other. So the data for the study came from fieldwork that I conducted in Anni in early 2020, and it's based on tokens for Vortex, which had approximately 630 clauses. From this, I managed to create 177 potential instances of complex verbal constructions, and after discarding all instances of tokens with outstanding analytic questions, I was left with 165 observations on which this multivariate analysis was based. So each observation was coded for 23 different variables So I created for normally the presence or absence, as well as the position or number of the variable where that was applicable. And I also quoted explicitly where it's impossible to tell or to decide between these codes due to a lack of information. Also, therefore, effectively cases of ambiguity. In the next slides, I will summarize the parameters I use for coding, but I do encourage you to pause if you'd like to see the exact questions. So first, I looked at the syntactic status of the construction. So what were the elements verbal effectively? Was each element a separate grammatical word? Were the elements contiguous? And did the construction function as a predicate or not? I also looked at the construction internal cohesion. So were there any markers inside the construction? Did any of the verbs carry any inflection? And were there shared inflection values across the construction for tense aspect mood, polarity, and illocutionary force? I looked at argument structure. So was there a single agent in the construction? Which verb element acted as the syntactic head? And then a bit opportunistically, I also decided to record the overt expression of arguments, as I felt that perhaps this would have an influence in the realization of complex verbal constructions, and I was using corpus data anyway, so I have that information. I did also look at phonetic realization, another perk of using corpus data. So I looked at whether both elements constituted separate phonological words. I looked at whether one of the elements was more prominent. Here I roughly used intensity as a crude measure. I also looked if there were pauses between any of the elements and whether the whole construction was realized in a single intonation unit or utterance, and utterance. And finally, I also looked at constructional semantics. So whether one verb was a semantic head, whether the ordering of elements was iconic or conventionalized, whether the resulting meaning of the construction was compositional, whether the two elements made a single event in the Chaffian sense. And finally, I did also quote the semantics of the construction. However, this variable actually wasn't included in the final multivariate analysis, but was just there for my reference in the end. So now I'll guide you through the results of my multivariate analysis and what hypotheses I generated from the insights I could see step by step. So first, we can see this kind of circle here, which is the result of all 165 tokens being clustered together. As you can hopefully see, about 3/4 of this whole circle is represented by a single cluster in pink, and the tokens in this cluster are mostly multiverbal expressions fitting this definition of a complex verbal construction. And so to locate you a little bit better at the examples I showed you earlier, indicated by arrows here. So the serial verb construction from example 1 is the arrow on the top left. The converb construction from example 2 is the arrow on the bottom left. And the clause chain, example 3, is the arrow on the top right, pointing something in the green section. So actually the constructions which do fall into this non-pink area are things like reported speech constructions, parataxis, and clause chains. So information helps us generate the first hypothesis, namely that these constructions are not complex verbal constructions. Now let's look at that pink cluster in a little bit more detail. And again, to orient yourself at the serial verb construction from example 1, you can find here in that purple section where the arrow is converb section, is converb construction is indicated by the arrow in the middle. So we do find quite a few tokens here. So let's see if we can make any generalizations. So the red cluster indicates some tokens in which the first element is referential and the second is the main predicate in the sentence. So these ones are not complex verbal constructions. They do not occur within a single intonation unit. However, all of the remaining tokens bar 1 do. This leads to the second hypothesis, namely that complex verbal constructions must occur within a single intonation unit. And this was also suggested by a lot of literature on serial verb constructions. So if we go back to this original cluster, it seems we can kind of split the remaining tokens into 2 further clusters. This one covered by the gray rectangle seemed to be roughly symmetrical in Eichenwald sense. So consisting of exocentric constructions with two independent verbs. And the ones in this green rectangle roughly appear to be headed constructions, which are conventionalized in some ways, kind of asymmetrical in Ackerfeld sense. So we can generate a third hypothesis that Kera'a has both symmetrical and asymmetrical SVCs, but we should probably investigate this a little bit further by zooming in first on the right branch of the tree to look at the symmetrical cases. And we can see within this cluster there are four main sub-branches. The branch in the purple rectangle actually indicate cases when it's not so clear what relation the verbs have to each other, whether these tokens are actually complex verbal constructions or not. And the one sole token outside of that original red cluster that wasn't realized in a single intonation unit falls into this purple red rectangle. So I have this red rectangle here, which covers mostly what seem to be symmetrical SVCs. Although when we look into it, some tokens are realized with a single phonological word, others with multiple. Similarly, some tokens are realized with a single grammatical word and others with multiple. So now I'll show you two examples of this where the telic affix tet delimits a grammatical word. So, a grammatical verb stem here. So an example 4, it comes after the first element. An example 5, it comes after both. So some of you may wonder whether give, an example 4, is a benefactive marker of some sort. However, the context in which it occurs suggests that it is a separate grammatical word, especially as it's used as a main predicate about 2 or 3 clauses prior. So it's important, I think, to note that despite the difference in word order, these examples were grouped together in this one cluster. We can probably actually group the elements in this blue box together with them. This is mostly covering symmetrical CVCs, but we see, however, in this green box that there are constructions which are perhaps a little bit more grammaticalized, and also surprisingly constructions with internal markers among the verbs. That said, example 1, the SVC does fall here, as well as an example which is formally identical to the converb construction from example 2. And seeing this, I asked myself, if the clustering algorithm is meant to group together tokens depending on the similarity, why something formally identical in a completely different cluster? If we contrast the two tokens, we can see that the difference lies into the context in which these two tokens were uttered. So for example 2, the object was realized in an earlier intonation unit, and it made it clear that the second element was the syntactic head of the construction. However, in example 6, there were no arguments overtly realized, so it meant that it was impossible to tell which verb actually controls case assignment. And when we look across all tokens, we find that this cluster, rather than representing symmetrical constructions, actually groups together instances where it's not clear which verb heads the construction syntactically. Here, controlling case assignment, in most cases because there was no overt argument realized. So this branch primarily includes meta CVCs like that of example 6, as well as synonymous SVCs and cause effect SVCs. So here we have an example of the letter 2. So in 7, we have eat or drink, and then 8, we have something kind of taken out, which was reflexivized to mean come out. So we should probably amend the third hypothesis rather than saying that we have both symmetrical and asymmetrical CVCs in Kera'a. Might be a bit more apt to say that context in which it's not clear which element is the syntactic head may play a role in the formation of CVCs. Let's go back out, zoom one level up, and now zoom in on this branch in the green rectangle here, which we see, unsurprisingly, there's still quite a few tokens to look at. There is one lonely token here highlighted in red, which interestingly is an instance of a clause chain realized in a single intonation unit. And I believe here that we likely have 2 distinct sub-events realized in a single intonation unit. And as suggested by the free translation, come was not actually translated explicitly by my consultants as a separate event. So here, the sole occurrence of a syntactically biclausal construction within an SVC-heavy cluster suggests that this is probably just a one-off immersion construction and sustains the hypothesis that clause-trained constructions are not actually proper CVCs. Unfortunately, it's not so clear what the other clusters here represent. The olive green and the blue branches seem to roughly represent tokens where it's not clear whether the construction is compositional or not. The right-hand branch here seems to consist of instances in which it's not clear whether the element ordering is iconic or not. And of these, the purple and pink groups mostly have motion verbs as the second element. The light blue group here mostly consists of tokens, where both elements are separate grammatical words and the second element is a proverb. So I've included here two examples. The first has a proverb meaning like this as the second element, and the second has which means do as the second element. And the large number of tokens within this cluster suggests the hypothesis that proverb SVCs form a dedicated CVC type in Kera'a. We can also look at this yellow group here and I found that it mostly consists of tokens with grammatical and second elements with some sort of modal or manner meaning. So here are two examples of modal SVCs in Kera'a. They're normally used with negative polarity, although 13 here can be used without being negated as well. And we have manner SVCs. Both elements can actually be verbs, which can be used with main predicates elsewhere, like in 14, but it can also include elements which appear to be kind of bound, like in 15. But more importantly, the manner element is almost always in the second position. So from this, at least two more hypotheses about the existence of modal SVCs and also a manner SVC template. So generally, this kind of main branch appears to represent conventionalized constructions, but not necessarily asymmetrical constructions in the icon sense. And if we zoom out once more, we can also hypothesize about some more general tendencies across the dataset after having looked a little bit more in depth. And it seems like features which are often seen as defining criteria for constructional subtypes, such as the lack of constructional internal marking, and the ability for each word to occur as a standalone predicate, were not actually instrumental in grouping together tokens for this cluster analysis. Which leads to the final two hypotheses I'd like to put forward today. Firstly, that the occurrence of verbal elements as main predicates is perhaps irrelevant for the distribution of CVCs in Kera'a, and the lack of clear influence in constructional term marking also suggests that this too is perhaps irrelevant for Kera'a CVCs. This does generate a sub-hypothesis of its own, namely that converb constructions do not form a dedicated construction type in Kera'a, and instead are rather an emergent construction type that speakers can make use of when they want to, as discourse requires it. So ideally in the future, I'd like to take these hypotheses and test them out through further corpus exploration and also in the field when field work in this area becomes possible again. I'd like to refine the parameters and coding as needed, as well as test this method with corpora from other languages and cross languages as well. And hopefully I can also conduct some further statistical analysis to determine the most important parameters. I'll quickly show you the references, as well as thank you very much for coming along to see. Thank you very much to the Kera'a speakers who helped me in Annie and Roy, and also to the DFG for helping fund this work. I also very much appreciate any feedback that you have about the study, and I look forward to discussing points of this analysis with all of you.